Hey, everybody. Welcome to Data Engineers Lunch number 12. We are Data Wranglers DC. So Data Wranglers DC used to meet physically. Nowadays, we do it virtually. And so this Data Engineers Lunch, we're going to continue doing it even after things open up, because I think it's great to have people from all around the world come and present and talk. Today's topic is introduction to SED for data engineering. If you have seen some of our previous videos or were here in the beginning, we went through a data engineer's roadmap. Like, what do you need to know to become a good data engineer? And one of the items we discussed was how to leverage Unix compiled tools, basically, to do data engineering. You don't need to have Hadoop and Spark sometimes just to process CSV files. So, so Arpan actually volunteered to, or at least I think I directed him in some way, but he has made a talk with some examples. I'm looking forward to this. I'm your now sole organizer because Akwi has gone to school to become or have a doctorate in, I think, cybersecurity. So we'll await his return. Until then, I'm looking for helpers. For now, just even if you don't want to be a co-organizer, if you want to just talk about something that's related to data engineering, love to have it here. We are part of a much larger community called Data Community DC, also lovingly called DC2 because it's DC. Where folks from various different backgrounds, and we encourage people in underrepresented communities to speak and present. We are one of many groups that have different focus. For example, Data Science DC, obviously data science, data visualization, statistical seminars, full stack DC. These are more kind of regional focuses. What do we cover? We cover the get your shit together problem in data. That's one of the biggest precursor tasks that we have to do before we can do anything else. First, we have to get it together, and then we have to clean it. Then we have to process it in some way before it's usable in a dashboard or data exploration tool, or even in data science or machine learning. So data engineer, we call it Data Engineers Lunch because we're really focusing primarily on the software engineering and a little bit of the data analyst, right? How do we communicate things? We're not talking about data science per se here, but we may talk about how to operationalize some data science process. We have a bunch of new folks. No pressure, but if you want to introduce yourself, just turn your camera on, unmute yourself, tell us who you are, and what you'd like to get out of the Data Engineers Lunch, what you could present on if you were given an opportunity. In the past, when we did this physically, people would get together and we would encourage them to speak to somebody they didn't know. So in lieu of a physical meetup, this is what we do. So Sachin, would you like to say hi? I think you've been here before, but I don't think we've seen.
Hi, hi. My name is Sachin. I'm currently in India. I can't switch my video on because my camera is looking at a weird place.
Okay, that's all right. Well, thanks. Yeah, go ahead.
I'm a PhD in public policy and data, and I was in George Mason. And now I'm right now at the Indian School of Business, where I'm on the faculty here on public policy.
Great, awesome. Well, thanks for joining us. I see A. Kinla. Do you want to say hi?
Good afternoon, everyone. How are you?
Hey, doing well.
It's my camera. I wasn't expecting to say anything. I just wanted to peep in. I'm also on the meetup with the group called Fed Data Engineers. I started maybe about 5 years ago. We got about 600 members. Nice. Every now and then I like to peek in and get some ideas of what other meetup groups are doing. I've been a software engineer in the federal government now for about 20 years. I've worked in DOD, NASA, Right now, I'm working over at the Labor Department. I specialize in financial application systems, and just happy to be here and hope to connect.
Yeah, that's great. Would be nice to have like a joint online meetup, you know, if you want to cover something together.
Oh yeah, absolutely. I definitely would be interested in that. Maybe some of your software engineers might want to know how to do a copyright or a patent on some of their ideas. I work a lot with lawyers, and I'm very much into this whole concept and idea of cyber civil rights.
Yeah.
Focus on privacy, data, the abuse of data in this whole cyber sphere that we're working in right now. So definitely we can connect.
I'm gonna send you a quick note on the Zoom chat with my email.
Okay.
Just ping me real quick so I can we can get that ball started. Okay.
All right. Sure enough.
Thanks.
I see it.
Awesome. We got Yin Kwan. Do you want to say hi?
Hey, I'm Rahul. Nice to see you again. It's been a while. I saw that you were hosting a meetup. And then
Oh, hey, I recognize your voice now.
Yeah. No, I was working for Deloitte last year. Now I'm working for a startup, and
Yeah.
so I'm here to learn more about SED. So nice to see you again. Yep.
Yeah, you know, it's funny. I was like, that can't be the same Yin Kwan. That's why I had to hear your voice to recognize you. Awesome. Thanks for joining. Appreciate it. And we have Curtis. You want to say hi?
Yeah, how's it going? So I've been to a few different meetups in pre-pandemic days. This is probably my first one, I think, since everything's been virtual. Or maybe I'm mixing up a couple different groups. It's hard to know. But anyway, I work. I'm at Ncbi. So Ncbi is basically PubMed and all the sequence databases. And so we've been pretty busy with COVID stuff this last year, as you might imagine.
I can imagine.
And so yeah, I'm just SED is one of the tools that kind of and putting off that becoming more and more pertinent to my work. So I'm really interested in today's presentation. So nice to meet everyone.
Awesome. Thank you. Wow, we have a lot of people. So what I'm going to do is I'm going to do it at 12:10. I'm going to stop with the introductions, and then we're going to get into the substance, and then we can still chit chat and talk afterwards. Anyone who want to say hi? You want to volunteer? Okay, no volunteers. Well, thanks everybody for joining. Group rules, if you have a question, just ask it, be polite. Some speakers may say that they'd prefer that you put it into the chat. I personally don't care. It's an opportunity for you to take part in a conversation. That's just the culture of our meetup, is that the speakers are not speaking to the folks, we're speaking with the folks that are here. So when you share, you're actually able to kind of add to the conversation. So for example, you know, if you've used SAD and you can enhance the conversation, we encourage that you do. Our company Anant is sponsoring this meetup. We also sponsor Cassandra.Lunch DC on Wednesdays, same time at noon, a different meetup link, obviously. We specialize in platforms related to Cassandra, Spark, and Kafka. DataStax is a sponsor of this group as well as the other group. So is GW University around the corner from here. They have not only supported this group, but also various other groups as an institutional sponsor of Data Community DC. We have some local sponsors as well as some institutional sponsors, such as American University, in addition to GW. Institutional sponsors are the ones that donate to our nonprofit foundation that allows us to back all of these different meetup groups, as well as do events like Data Week DC, which we did online this past year. Any announcements? Anybody looking for work? Anybody have a job to offer? Any upcoming events that you wanted to do a quick shout out for?
Actually, this is Curtis again. I think we're going to be having some external. We have to use the word codathon, not hackathon.
Yeah.
But if there's anybody in the sort of biological spaces, particularly bioinformatics here by chance, this might be something of interest to you. You know, we host some resources on AWS or GCP typically when we do these things, but they're kind of based on kind of medical stuff. And so if that's of interest, feel free to chat me.
Yeah, if you have any links, you can put them in the Zoom chat, Curtis. Feel free.
I'm actually just gonna send my email because like the specific events that are coming up aren't kind of like fully there yet, but they're on the pipeline and stuff like that. So if people were interested, yeah.
Sure. No, that's great. We do have a few upcoming events as part of Data Community DC. Here, I'm just going to bring it up and we can go through them real quick. So we have text mining and music mining coming up on Wednesday. Data Visualization DC has a few monthly meetups. Stats usually has like a seminar, like you can go learn. I don't think they have scheduled it here. And yeah, I'm looking at a different group here, but and I'll go through, but generally there's always something going on. All you need to do is to go to Data Community DC and click on the meetup groups. And with that, I'm going to hand it over to our speaker, Arpan.
Oh, hey everyone. Thanks for having me. I'll go ahead and share my screen. Okay, can everyone see the slide deck?
Yep.
Great. As Rahul mentioned, we're just going to cover a basic introduction, like when we were going through the path of a data engineer. SED is one of the command line tools that you should be familiar with. Today's topic is just going to be an introduction to SED and how we can use it for data engineering. We're going to give a couple of examples and then do a quote unquote real world example of how you could use it. As Rahul also mentioned, this is a community-driven presentation. So if you have any input, go ahead and speak up. The more you know, the more everyone knows. Yeah, so let's go ahead and get started. So if you're not familiar with what SED is a stream editor, and it's a non-interactive command line text editor. So when it means non-interactive, it's less dynamic in the sense of how you can use it, but you can still do a lot with it. SED is commonly used to filter text. And when you say filter text, that includes taking text input, performing some operation or a set of operations on it, and then outputting it, the modified text. Typical use cases of using SED is extracting part of a file using pattern matching. And pattern matching, you can do regular expression. You can substitute multiple occurrences of a string within files, so you don't have to use this big bulky tool like Spark to do something. If you just need to replace, or if you need to substitute some kind of text string, certain words in certain things, and then just output it to a new file, you can do it very simply with SED. And then it also, again, it supports basic and extended regular expressions. If you're using the GNU SED, I think Mac has a different version. In ours, we'll be using the GNU version, and we'll be doing the demo on Gitpod. And so that way, you don't need to necessarily download any software onto your local machine. Say if you're running on Windows, I'm pretty sure SED doesn't come included on Windows. Yeah, so you don't have to download, install, add anything to path. You can just open this up in Gitpod and just follow the instructions on the GitHub repo.
It's part of Ubuntu, which is part of now Windows subsystem for Linux, but it's not inside like PowerShell. Yeah.
Gotcha. So yeah, so a little more breakdown of how SED actually works is, so it sequentially reads a file or an input pipe line by line into memory, and then performs all the actions that are specified on that, puts it back into memory, and dumps it to the terminal. So default, what SED does is when you make any kind of edits or substitutions, it displays it to the terminal. But then we'll go into all in the demo how you can potentially create new files, overwrite the input, et cetera, et cetera. But essentially, once it does once it finishes that process for one line, it moves on to the next line and keeps going through the process. Again, the default output is to display the contents of each line on the terminal or the screen specifically, or sorry, the terminal specifically. And again, as I mentioned, it can be redirected to a new file, or you can overwrite the input file itself. And then more on top of how it works, it's the default for sed is to read the entire file, but you can restrict it to specific lines as needed, and we'll cover that a little bit in the demo. So the basic syntax of a sed command is you would do sed, and then you would have your options. So depending on the type of operation you're trying to do, say if you're using a script, so you have your sed operation or your sed commands written in a script file, you would append a dot or flag F. If you're using regex, there are certain commands for it. But generally, if you just have basic regex, you don't need the flag for it. But I think if you have a more complicated version, or if you need extensions, there's a flag for it, and you can find that in the documentation. And then also, if you're doing like overwrites, there's flags for that as well. And so the options and the command lists are available, and I have them linked in the slide deck. And the slide deck will be available once this YouTube video goes up, so most likely tomorrow or the next day. But back to the basic syntax. So after you have the options, so your flags, the command, and those are contained within single apostrophes. If you have compound commands, you can use two methods, and we'll cover that once we get to the demo. And then if you're extracting to a file name or your input file, you would include the file name there. But if you're using a pipe, you don't necessarily need to include a file name, and we'll also cover that in the demo. All right. And before we move on to the demo, I'd like to open up the floor to any questions, or if anyone has any input that they would like to add, they can go ahead. Okay, looks like no questions. So I've already built this repo for you, and I will send it into the chat, but essentially it's the, let me find the chat. And essentially it's just commands and methods to do a introduction to how sed works, and then we'll take what we learned there and apply it to a real world situation. Again, this is just an introduction, so it's not super complex, so people can still follow along as we go through it. So essentially what we're going to do is we're going to show you how you can read lines using sed, how we can delete lines using sed, how we can make substitutions, how we can write changes to a new file, and then how we can use sed, again, like I mentioned with the script. So if you have your commands written out in a script, you can use that, and then we'll move on to the quote unquote real world application. All right, so I've already opened this in Gitpod, so everything's ready to go. And as I mentioned, Gitpod provides everything for us, so we don't need to download anything new, and everything's available straight in the terminal. So all I'm going to do is I'm just going to go through the GitHub repo. Let me move this chat window. There we go. And I just have it in a second screen. So I'll just be copy and pasting commands and talking through it. So we're going to start off by using this lyrics.txt file. So in this lyrics.txt file, we have the Thundercats theme song. And so we have line breaks per line. So we have the first stanza, or I don't know the exact musical term for it, but we have the first line, second line, et cetera, et cetera. And then we have this chorus section where we notice that there's repeating values. So we'll expand on that once we get to that section of the demo. But first, we're going to start with how we can read lines. So there's two methods we can use to read lines. We can use the pipe method, and then we can read it directly from the file. So this first method is going to be using the pipe method. And so what we're going to say is we're going to do a cat lyrics.txt, and then we're going to use a vertical line to signify the pipe. So we're saying our input is the output of the cat. So when the cat reads lyrics.txt, take that output and then pipe that into sed. And so what we're doing here is we're using flag n as an option. So essentially what flag n does is suppresses output. So when you use this p command here, that's essentially saying print these lines, but it'll automatically print or sed automatically prints output. So we have to use the N flag to suppress it and only output what we want. So what we're saying here is saying, take the output of the cat and then using sed, print out lines 5. And when you have a 5 comma 8, that's the range that we're printing. So we're saying 5 to line 8. And so when we do that, it would, if we did not have this flag N, it would likely output the entire thing. So we're just saying only give us back lines 5 through 8. And if we look at our txt file, and it does that exactly. So we can do the same exact thing. Instead of having the cat lyrics.txt, we can say sed n apostrophe 5 comma 8p apostrophe, and then we put the input file there. So instead of doing a pipe, we're just doing direct from the input file of lyrics.txt. And that's a very simple way of just reading specific lines that you need. And then you could potentially use that and export it elsewhere. And we'll talk about that a little bit later in the demo. But another way you can also read lines instead of using the 5 comma 8 is you can do a 5 and then have a comma and then a plus, an integer value. And what that says is when you, or let me just go ahead and paste it. So in this example, we're saying 5 comma plus 3. And we're saying with this plus 3 is we're telling sed to operate on line 5 and then the following 3 lines. So we're still reading lines 5 through 8, but say if we change this number to 5 plus 4, it would read lines 5 through 9. So we're still reading lines 5 through 8 because we just put the number of 3 in. But again, if you change that, it's just a way to a different way to operate on the range of lines you're working with. And so those are just a few ways you can read lines. And then we can do very similar things with deleting lines. So again, there's 3 methods we can do. We can do the cat pipe, we can do the input file, and then we can also do the range operate with the plus sign. So in a deletion, I'll go ahead and clear the terminal real quick and make it a little bit bigger. We're saying cat lyrics.txt, so we're using the cat pipe, and then we're saying sed delete lines 5 through 8, right? Because we're using the range of 5 comma 8. And then instead of using a P, we're doing a D, which is the command for delete. And so if we look back here, we've deleted lines 5 through 8, and correctly, it's returned only lines 1 through 4 and line 9.
Hey, Arpan, Sachin had a question.
Yes.
He said, can you do reverse like 5 comma -1 to like go up?
I didn't come across that while I was reading through the documentation and preparing this. If someone knows the answer, they're more than welcome to answer.
I don't know. We could try it. Try doing you know, like, yeah, like I guess that, yeah, well, you had the +3 and probably try to do like -3. Yeah, you just had it. There you go.
So I think it might not work for the +3 because that plus is signifying operate on these additional lines. So perhaps if I do it on the just a single range. So if I do 5 -4.
No.
Yeah, perhaps it doesn't like that minus sign.
Yeah.
Yeah. So perhaps not such an. So yeah, going back to the delete. So we took a look at the cat when you take the cat pipe. Oh, see, Ion has a response. So it's essentially using. So if you look at what Ion said in the chat, we'll get to that point later. But essentially, when you see these semicolons, you're saying this is a compound sed command. So the first set is !G. So the G is a double spacing command. The exclamation mark, I just had it. Sorry, I lost it. I told myself to remember it, but I lost it. H is for using a buffer, I believe. And then the $ signifies the end of a line. And then we're saying delete the end of it. But again, the exclamation mark would change the syntax of what that means. And then temp test. So this is the file. Yeah. So this could be a command. So depending on what your input file is. So if your input file is temp test, it would do a reverse on that specific file. But yeah, so in a similar vein, if we do sed 5,8, so delete ranges 5 through 8, and then using temp test like Ion said, we would just do lyrics.txt and it would return the same thing. And again, if we use the plus operator, it would delete lines 5 and then +3, so the next 3 lines as well. All right, so now we can also use patterns. So when we're doing deletions with patterns, I'll show you the syntax first. So we're saying sed, and when you have patterns, you have to include them with slashes. So it would be in your apostrophes, it would be /thunder. So what we're doing here is we're saying you sed, when you read these lines and you see the pattern thunder, delete that line. And that's what it did, right? So it took any of these and it read through each line. So it says, oh, I see lowercase thunder, delete that line. Oh, I see lowercase thunder, delete that line. And essentially it did that for each of the lines. So it returned back every line that did not include a lowercase thunder. And now say if we wanted to compound this, there's 2 methods to do it. So the first method, so we talked about the semicolon, which is the first version, but there's also using the flag E option. So in this one, we're going to say sed E, and then again, take the pattern. So the first pattern is thunder, and then we're also going to do deletions on patterns that are in lines that contain the pattern of magic, a lowercase magic, from the input file of lyrics.txt. So if we look at the file, we see, okay, no magic, no thunder. Oh, we see a magic here in line 3. Curtis, I believe so. So Curtis asked, why did it delete the entire line? So the fundamental unit for sed is always the entire line unless otherwise specified. Correct. So it suggests on the documentation, if you're doing deletions where you want to delete single words, you're better off using the substitution command. So you would do a substitute, look for the pattern, and then substitute it with either like a space or a blank or a comma, etc. So if you don't want to delete the entire line, use the substitution instead. And we'll get to the substitution in a second. But yeah, so moving back to the example, we deleted this magic. So if we go back here in the output terminal, we see that thunder on the move. So the first 2 lines come through, but then line 3 is gone, right? Because it found that magic pattern, right? And so then it also still deleted lines 5 through 8, which was expected, which we just did. And so we were able to compound multiple sed commands to delete multiple lines. So now another method, as Ion showed, is using the semicolon method. So instead of having multiple flag E's, if you have a compound command that you want to run, you can either do it 2 ways. You can do it multi-line or you can do it single line. So in the example Ion provided, it's a single line command, and we'll show you how to do that. But first, I'll show you how to do a multi-line version, just so we can see the breakdown a little bit easier. So we'll say sed apostrophe, and when you're working in a Linux terminal like Gitpod has provided us, when it recognizes sed apostrophe and you hit enter, it'll automatically create these extra lines, and it won't exit the command until it recognizes a trailing apostrophe. So what we're saying here is look for the pattern of thunder and delete those lines. And then that's the first command, and we append that with the semicolon to signify that's the first command. And then we say look for the patterns magic, and then delete those lines. So we don't need a semicolon after that one because that's the last command. But essentially, if we run this, it'll give us back the same exact output as we did when we're using the -e method. So the semicolon's a little bit cleaner, and it's more, I guess, pretty to work with, especially that you can do multi-line, and it'll just be easier if you have more complex commands you're running. It'll just be easier for everyone to do. So again, instead of doing the multi-line semicolon option, there's an option where we can do it in a single line. So we're saying here is sed, first command, look for thunder, delete it, semicolon. Second command, look for magic, delete it, and that's it. So when you're using compound and complex sed commands, generally people use semicolons. So if you're looking at someone else's code or someone else's commands, and they're using semicolons and you don't really understand what that means, it essentially just means it's a compound sed statement. But you can also use the flag e's, but I don't think they're in use as much, but it's just good to know that that's another way of doing multi-step commands. So now we'll move on to the substitution portion. So substitutions are a little tricky if you're not familiar with them, just for the initial part. So substitutions work for the only, I won't say only, substitutions work for the first occurrence of the chosen sequence in a line unless specified. So if we look at this thunder, if we run a substitution that looks for the pattern thunder, it'll only act on the first one, and we'll show you what that looks like. So in this command, what we're doing here is we're saying sed, and when we're doing a substitution, the syntax is '(s) to signify substitution. The first item that goes after that is the pattern you're looking for. So you can have either text or regex, whatever you're looking for. So that's where regex can come in handy, especially if you're looking for complex, or if your patterns that you're trying to extract are complex. So regex can come in handy there. And then the thing that comes after that is what you're substituting in for that. So whatever you're searching for, substitute it to this. So what we're doing in here is we're saying substitute any pattern thunder with lightning. However, because we did not specify to do it for every single one, only the first pattern gets changed in each line, right? Because I just mentioned substitutions work for the first occurrence. So how can we go around this? It's very simple. We just add a global option. So the way to do it is take the same exact line, and after the trailing slash, add a G. But when I run this, it works as expected. So we were able to take every occurrence of lowercase thunder and substitute it with lightning. So we're saying here is Thundercats doesn't get affected because it doesn't match the pattern of just thunder. And then, so we see the capital thunder, again, it doesn't match the lowercase thunder, but every instance of lowercase thunder was correctly substituted with lightning, versus if the command we ran without the G, it only did the first one. But when we included a G, it did the global option, and it did it for each occurrence. But say we also want to change the uppercase to lightning as well. So what we could potentially do is an append. So keep the global option, but then also add an I option to essentially say, look for case insensitive versions as well. So if I paste this in, so we're just the same exact command, but we're adding an I. However, wait, it did some weird things. So it also changed the uppercase thunder of the Thundercats to lightning. And that's something we did not want to do. We only wanted to change this uppercase thunder, but it affected way too many things. So what's a different way we can do this? We can go about it two different ways. Or sorry, we can go about it a couple different ways, but this is just the way I have it. So what we're going to do here is we're going to make a compound sed command. So we're going to say sed substitute lowercase thunders with lowercase lightning and do that globally. And then also with the semicolon, because it's a compound command, substitute uppercase thunder with the comma, right? Because if we did not have the comma, it would also substitute these uppercase thunders here. But because we're adding this comma here, we're specifically saying, look for this pattern. Look for this pattern. Because if we didn't have the comma, it would trigger on this pattern here. So we're saying thunder, comma, is the pattern to search for, and then substitute it with uppercase lightning, comma, and then take that for the input file. And so we run that, and it's outputted what we actually wanted. So we wanted to keep Thundercats the same. However, we wanted to change the chorus to say lightning. So it's instead of thunder, 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 Thundercats, it's lightning, 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 Thundercats. So that's just a couple different ways where you can do some sorts of substitutions. And then also another thing we can do on top of this is we can also print the lines that we substituted. So if you want to kind of make a makeshift log of what is happening, we can say sed flag n, again, remember that suppresses output. And we're saying make those substitutions, but then also print it. So we're saying GP. GP is for the printing. And then the same thing, so global and then printing, and then take the input file. When we do this, we'll get back 8 lines. Because remember how sed works. It works line by line. So what happens is this first output, it matches the first command, right? So the first command changes the lowercase lightnings. And then the second command changes the uppercase lightnings. So what's happening is each pair is essentially per line. So this is the first command of line 5. This is the second command of line 5. And essentially that happens 4 times in total, right? Because there's 4 lines that repeat in the chorus. But yeah, that's just a couple different ways we can do substitutions. Again, we'll do a little bit more complex when we get to the real world example, but this is just an introductory way of how you can use it and how you can potentially expand on it. So next, we'll take a look at writing. So when we're using writing, let me go ahead and clear this. There's 2 methods we can use. There's the flag I option, and that is the overwrite, right? Because you don't want to always overwrite something, but if you need to overwrite something, you need to append a flag I. The second option is using the greater than caret. So the greater than caret creates a new file. So essentially what we're going to do is in this first example is we're going to show the the caret method. So the caret method, so what we're saying here is make those same changes we did in the substitutions. So ideally what this outputted edited.txt file should show is lines 5 through 8 should be lightning, uppercase, thunder, thunder, or lightning, 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 and that should repeat for lines 5 through 8. So we're making those changes, the substitutions, and then we're saying from the input of lyrics.txt greater than create this new file called edited.txt. When I run this, we'll see in my GUI, we see an edited.txt, and I'm just going to do a quick cat on it and we'll see it, right? So it correctly took our commands and outputted it into a new file, right? As expected. So lightning, 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 et cetera, et cetera, et cetera. So another way we could potentially do some writing is using the I flag, which is overriding. So what we're going to do here is we're going to say sed I, but then also what we're going to do is create a backup in case, I didn't really mean to do that. I want to go back. So what we're going to do is we're going to say sed I, which is doing overwrite, and then we're going to append a .bak file type, and that's essentially going to create a backup of the input we're using. So we're saying sed flag I.bak, do those same substitutions, but instead we're reverting back to the original methods or the original text. So we're saying take the lightnings, put them back to thunders, take the uppercase lightnings and put them back to uppercase thunders. And then we're saying use edited.txt. And so when I run this, we see that now we have this edited .txt.bak file. So if I cat edited.txt right here, we should essentially get back the same exact stuff because, right, we used flag I, so we overrid it. So it's back to normal, uppercase thunder, lowercase thunder, etc., as expected. However, say, I liked it better with the things we changed. If we just run the cat edited.txt.back, which we created with the flag I.bak, we get back the original version we did before the reversions. So we kept and persisted the lightning version just as a separate backup file. And that will cover up, some basic methods for writing and just a couple of examples. Again, you can make these a lot more complex than what they are, but this is just an easy way to get into it, just a simple tutorial. But now we're going to cover scripts. So scripts, it's very similar, but instead we are going to use the flag F option and a script file. So in the repo or this GUI that we're looking at on my screen, we see this list of commands. So what we're saying here is we're saying N, which creates a new line. We're making a substitution. So we're saying substitute within the first set of slashes. \n means every new line. So substitute, look for new lines, and then substitute it with the period and a space. So what we're doing here is we're going to take this input file of lyrics.txt. We're going to number it so that way you can see the line numbers and then put them all into a single line. So the way that we can create line numbers using sed, it automatically makes a sorry, I'm blanking on the type of new line it creates, but essentially it creates a new line and pushes everything down. So looking at lyrics.txt, so above line 1 would be 1, and then it would be the first line, and then it'd be the number 2, and then the second line, the number 3, the third line. So essentially what we want to do is instead of having that staggered approach, we want to take it, make some substitutions, and bring it all into one line. So the way we're doing that is using N, which is the method for creating a new line. We're substituting the new line break and appending it with the period slash, and then we're going to use G to double space it just to make it a little bit more readable. So before we do all of that, we need to make lyrics.txt have numbers. So the way we can do that is using the equal operator. So that essentially says it takes the current line input number and then it adds a trailing new line. So we need to substitute those new lines out so that way we can move the lines back into a single line per line in the lyrics.txt. So if I'm just going to copy and paste this in, so essentially talking through it, sed the equals operator, lyrics.txt. So what that first part of the pipe does is it numbers the lines. And then the second option uses sed. So we're taking the output of the first part and piping that into the second sed. So sed flag F, so that's signifying we're using a script file, and then scripts.txt. So then it would operate using these commands. So when you have a script file with sed, you don't need any semicolons and you don't need any apostrophes. And you can do each separate command on its own line. So again, just talking through what's happening. If I just do a sed lyrics.txt, sed equals lyrics.txt, just so you can see what it looks like and what we're working with. So you see how it's line 1, the first line of the text, line 2, second line of the text. So what we're doing with these operators is we're saying, take these, get rid of the new lines, move these up, and put a period instead, or put a period in front. So moving from this, so this is the output of the first part of the pipe, and then this would be the output of the scripts we're running on top of that. So we used a compound command just from a script file. And we're saying it's just an easy way to keep track of what you're doing and make edits as necessary. But yeah, that's just a little bit more of a complicated than we've done so far. But it's just to show you the power of what sed can do and how fast it is. All right. So now we could move on to the quote unquote real world application. So say in this real world example, we get a CSV file from someone in our company or a team, and they tell us it has some issues. They notice that the first field, so like column 1, is missing a value for at least one row, and they're not sure how many other rows are affected. How can we approach this problem with sed? So first things first is we can do a grep just to see how many rows are affected. So when we're using CSVs with empty values, we can use a special uppercase caret, C-A-R-E-T, caret, and a comma to signify it's an empty first value in the row, and then it has a comma. So we're just going to do a quick grep. And we're going to say grep, caret, comma. So look for items at the beginning of a row with the comma from our CSV that our team member handed to us. So we see that there's, oh man, there's at least 10 records or rows in the CSV file that are affected and that are missing empty values for the first field. So how can we use sed to move this along and to potentially isolate the problem, figure out what records are issues, make a stopgap, or just delete these records in general? And we'll go through that. So now that we have these 10 rows, the first method we could do is isolate them. So we can take, or more than 10 rows, I think there's like 14 or 15 rows. But essentially take these rows, put them in a new file. So then we can hand this to our data team or database team and say, these rows are affected, do something about it. So what we can do is there's two methods. We can use this grep output as our input pipe, or we can do a sed directly on our input file. So I'll show you both methods. So what we're going to do here is I'm just going to close out of these. Is we're going to say grep. Again, it's the same grep we just did. And then we're taking the output of that, and then we're running some substitutions on it. So we're saying sed n, again, remember it represses outputs, make a substitution at the beginning of a line with the comma. So find what that grep showed, substitute that pattern with something called missing summary and account for the comma. So we're adding a comma here, and then print those lines. So extract and show only those values, and then export it to a file called missingitems.csv. We can do the same exact thing instead of keeping this. Oh, we can do the same exact thing without having this. Sorry. We can do the same exact thing without having this first part of the pipe. And we can just say the second half and then just put a spacecraft journey catalog.csv in front of the greater and. So use that as the input file. So if I just run a cat missing items.csv, again, remember, that's the CSV that we just created with the isolated records that are missing summaries. And again, we substituted the missing field for missing summary. And if we do that, we get back a CSV. So we took these empty ones that used just to be a comma. So we've now inputted something for that field saying missing summary. And again, this CSV here is about 1,000 records. So sed was able to do it like that. That's how fast it is.
And that's on a Git pod container.
Yeah.
It's not even on a real machine.
Exactly. Yeah, and so it was able to look for these items, substitute the values, take the output, and then write it to a new file within a second. But essentially say, okay, so we've isolated these records. We can take these, give it to our data team, give it back to the team member and say, these are the records affected. Or what we could also do is, now that we have the corrupted data, is we can make a new CSV that does almost the same exact thing, but as a stopgap, it still keeps the records, but again, it just updates the fields or the rows that are missing values for field 1. So what we can do is run a sed, substitute the same substitution command, but this time we're not isolating them with the flag N and P. We're keeping the entire output, and we take that entire output and we write it into a CSV called updated items. So to confirm that within this still 1,000 record CSV, these missing summary values have been updated correctly. So we can just run a grep on it. So we just say grep missing summary in the newly created updated item CSV. So we see that these values are no longer quote unquote corrupt. We have a stopgap just saying these items are missing summaries. So we were able to make some quick data changes and pass it back to our team. So it's just speeding up the process of something you can use or speed up the process using something like sed. So the last thing we'll cover is instead of keeping these records is, okay, the team just says trash it. So how can we generate a new CSV that are lacking these missing records? It's a very similar thing. We covered that in the basics. We use the D option to delete the entire line. So we'll look for something that matches a pattern. If it finds it, delete that line. So all we do is say sed, this is the pattern we're looking for. So caret, comma. So if it's an empty, at the beginning of the line, if it's empty with just a comma, that's the pattern we're looking for. Delete that entire line. And that's it. That's all we had to do. And then we say from the input file, create a new CSV called removed items.csv. And if I do a grep on that, looking for the pattern of caret, comma, nothing comes up. And that's great. So just to confirm, so if I go into updated items.csv, so this is the one where we substituted and kept the rows. There are 1,000, excuse me, 1,001 rows. That's because we have the header in the CSV. And then if we go into removed items.csv, there are 997. So about 14 records were deleted, and that was expected. That's what we wanted to do. And so we were able to use sed for a quote unquote real world example. If someone gives us data, how can we quickly and easily manipulate it in a structured manner and hand it back to them as fast as possible using a command line tool like sed? And that's about it. That's how easy it is. That's how you can do text operations, substitution operations, deletion operations. Instead of using something bulky and big just to do something this small like Spark. Yeah, you can do the same exact thing on Spark, but to do it this fast and this easily, maybe not, depending on the scale of your data. But yeah, that wraps up the demo portion of it. If anyone has any questions, feel free to ask. But other than that, okay. Okay, Curtis asked, his main issues with sed is that infrequent use, that he forgets the syntax each time. What's a good sed cookbook or quick start resource for it? So I recommend using GNU's, actually I have it pulled up right here. So there's this sed manual, Curtis, that it provides, and it shows you all, or let me pull it down into the screen. So yeah, it essentially is like the documentation for it. So it gives you the sed script input file, and it gives you all these examples. So if you forget where you're trying to do, it gives you everything you need. And that's available on the GitHub repo, but let me send you the link itself in the chat. There you go. And so that's just like the GNU provided documentation for sed. So is it actually good? Is that in terms of sed and normal, or like the documentation? Because
No, no, yeah, I was just making the point that like often, built-in documentation can be pretty bad depending on what it is, right?
Yeah.
So I was just glad to hear that. Yeah, you've used it. You recommend it. You go back to it, right? So it's worth going back. It's worth having it, basically.
Yeah, yeah. I definitely peeked back at it a couple different times because, again, like I mentioned, like with the G, or like the N or like the H operators, where it's like I see that in an example, but like, what does it really mean? So if I look for buffers, it'll give you examples of how to do it. So like you have these H's here, the N, the P. So it gives you examples of the operators and the options and the commands. So that way you can apply their example to what you're trying to do. But yeah, as Raul mentioned, there is a blog post that you can find this at. And all of the resources will be available that I used, and that.
Yeah, so I mean, actually, let me ask you about you pointed to the end, because I was looking at when you got to your script part, my brain was hurting because I was expecting to actually see everything on one line, but that's because it added an additional line at the start for every single existing line. So the replacement of the \n only happened for the original file, but all the extras made it such that there was still the same number of lines.
Yeah.
Like, in other words, it happened for every line, and then all right, now the next operation, whatever's there now is what it's gonna like operate on.
Yeah, exactly. So like what these two do together is it takes that new line and it shifts it up. So like, remember we saw 1 text, 2 text, and it takes those line breaks and it essentially signals it and then does that substitution with the \n saying this is the new line break. Let me see, where is it? Yeah, so sorry, n appends the line. So like it takes those I keep forgetting what the type of new line that the equal operator creates, but essentially is what we're saying is take those newly created lines with n, append those lines from the input, and then do that substitution where it removes those new line breaks and puts them into a single line, if that makes sense.
Yeah, the second time around, it becomes more clear.
Yeah.
I wanted to add to that kind of the usefulness here is that, so much of the pre-processing before we get into computation is like cleanup, right? And it's sorting. When you combine sed with awk and sort and unique, you can do basically SQL-like selections, right? Criteria selections before you get to maybe to put it into Spark or to put it into Hadoop or put it into a database. And the other thing that I don't think it's apparent is that it's a stream. So technically you could pipe everything. So you can be streaming. You can be writing to like a file is basically like in Unix, it's just like it's a stream, and you can have a live stream essentially. So you can be piping stuff to a file and have something else kind of pick it up, or you can just say pipe it all the way into wherever you want it to land. It's a different topic, but there are tools that do like export, right, from the database into CSV, and you can do a CSV into a database. Like technically you could say export, write it to this pipe, do a sed replacement, and then put it directly into an import database, and it should technically work. So it's kind of like magic. Once you get it to work, it's kind of like magic how fast it is. There was like a blog post that I read about the speed comparison between sed awk to do some basic transformation of data versus like a Python program or like a Scala or a Java program. And those are kind of like compiled. I mean, they're not truly compiled. They're like just in time compiled. and said was faster because it's C. It's written in C, so it was able to get it immediately. Right, there's no garbage collection. And then compared to like running the same process on Spark, it like took minutes for the Spark thing to even come up before it was able to even like start to process it. So awesome. All right, well, folks, we are at the top of the hour. We generally go for an hour, and I want to respect everybody's time. Arpan, thanks for putting this together. Hopefully you can have a follow-on with like how to use SAD and awk. Because those two are like Batman and Robin. I mean, you can basically take care of anything with those two tools. And then also, just want to quickly show you guys the brief look at what is available on the webinars that are already recorded. Let me share my screen. So, and all of these I think have blog posts, right, Arpan?
Yeah.
Yeah. So on the first data engineers lunch, we had our general roadmap of what all the things that a data engineer needs to know. And we're just kind of like moving through each one. And if there's anybody that wants to present on any aspect of data engineering, we're just going to schedule you in the sequence somewhere, right? And then there's also other topics that people have brought up that's in the backlog here. And, you know, we're going to get through it one by one. So we have enough ideas for topics for, I don't know, and until the end of 2023. But if you have something that's cool, we want to prioritize that. This is a community, and your voices are all important. So we'd love to have you guys present, you guys and gals and anybody else. Okay. Thanks everybody for joining us, and please join us next week, same time, same place. Take care, everybody.
All right. Yeah, thanks a lot. Take care.
All right, bye.